the Bigo. I am Ojaswit and I'm with my fellow teammates Sankalp, Abhijit, and Abhishek. So, recently we organized a national level hackathon and we hit a massive bottleneck finding the right judges and sponsors. We tried everything. Manual research was completely unscalable and a lot of work. So, we tried what we know best AI automation. But we found a critical flaw in all of the existing AI automation tools. These models suffer from catastrophic overconfidence. They would assign a 95% confidence value to something simply based on a single keyword, which was actually completely irrelevant. Simply, this is called calibration gap. In a production environment, uncalibrated scores don't just waste time, they destroy your reputation because they get flagged as spam. Now, we realize that the industry doesn't just need another system that generates more text. What it needs is a system that mathematically quantifies uncertainty. That's why we came up with the motivation to make the outbound machine. And seeing the problem statement, we knew it was our chance.
So, hi. So, the core innovation which we came up in our system is what we call as conformal safety layer gate. So, in most AI systems, the classifier output only a single probability scores, and in practical world, when we are measuring human conversations, which can get pretty random and pretty stochastic over time, the system encounters a problem when it encounters slightly different data than it was trained on. So to address this, we use a statistical method called split conformal prediction. Instead of forcing the model to commit to a single outcome or give me a particular single confidence score on a single predictions, it produces a set which is called a prediction set. A prediction set is a small set of plausible outcomes that reflects how confident the model is. For example, if a model gives me a set with a long number of predictions, it means to me that the model is very uncertain and it needs more context. So we can just stop the execution there and get more context or put a human in the loop. And if the set is calibrated using a separate holdout set, which allows us to select a threshold amount of reliability which we want. For example, let's say 90%. And when the model is confident, the prediction set is narrow and it will include less amount of outcomes in those set. So our system detects this uncertainty, and this behavior is not based on any heuristics or manual rules. It is supported by a statistical guarantee that the true outcome will always lie within the prediction set, and as a result of this, the system will avoid acting on low confidence intents, which will in result increase our success rates on the replies and on the outbounds, as well as reducing the LLM calls, which in turn will reduce a lot of costs.
Okay. So as we discussed, while the conformal gate keeps the um, low value, like low data score from the actual good data. So the entire architecture is on AI agents. So we use 5 tier AI agents. The first agent is planner agent. Planner agent basically when you give a subtask, it divides the subtasks into smaller subtasks into a DAG. And basically what the planner agent does is it forces the agents to collect information, which is then passed to the the gate one, which basically checks if the total information about the person or the company is sufficient or not. If it checks if the prediction score or the prediction set is good enough or not. If it's not good enough, it will not let the it will not waste the inference call, as inference calls are expensive, and it will just discard the lead. If in case the lead is good enough, it will call all the inference call using LLMs, and then it will have another inference call. It will have another gate, which will check if the generation, the quality of the message, the quality of the response, the quality of the outbound message is good enough. If it's good enough, it will pass down and it will actually send the message. So in this way, we reduce the LLM cost and inference cost, which is the most expensive part, by 40 to 60%, because all the bad leads are deleted in the first pass.
So crucially, this architecture gets smarter each and every time. So we built a data flywheel. Every outcome, whether it's a reply or a feedback or a rejection or anything whatsoever, it gives a feedback to our calibration set, which Sankat mentioned. So this tightens our confidence bounds, reducing the abstain rate and increasing autonomy with every campaign. The economic impact is massive. We are addressing an 847 billion inefficiency in sales and hiring market. So outbound machine moves us from artificial intelligence to what we can term it as reliable intelligence. It allows human to define the strategy while the machine handles the execution in the top-notch perfection. uh, Machine can execute in a cheap, safe, autonomous way rather human can ever execute. So the technology is ready and the math works. So yeah, that will be it. Thank you.
Thank you.